Hello, I'm Philip Muggleston, and in this series of videos we're covering the predictive capabilities native to SAP HANA. In this video we're going to look at DBSCAN, which is one of the new algorithms added to the predictive analysis library in SAP HANA SPS 6. Now DBSCAN may make you think of database scanning, but in fact it's a clustering algorithm. It stands for density-based spatial clustering of applications with noise. And it's a very powerful algorithm. Now, you'll certainly want to go to the documentation, the PAL user guide, which I've got here, and I'm just going to search on DBSCAN, and here you'll find all the details about how to use it. So it's within the clustering section, and there's DBSCAN, and we'll find the page. DBSCAN is very useful for two particular reasons. One of them is that you don't have to actually know how many clusters you want to create in advance. If you're using k-means, and you've seen the videos of k-means, then with k-means you have to say, I want to create 2, 3, 4, 5, or however many clusters. You need to decide that in advance. The advantage of DBSCAN is that it actually works that out itself. And it does that using a slightly different approach to k-means. It's also very flexible because it does a lot of things automatically, and it can also identify clusters that are maybe shaped in an unusual way. So let's not get too much into the technical details of the algorithm itself. Let's see how you actually start using it. A straightforward example using the PAL. So we've seen from other examples we did with the PAL and with k-means, for example, we've got some customer data. Here we've got about 150 rows. We've got for each customer an ID, their name, and then their lifetime spend, new spend in the last quarter, income and loyalty. And what we want to do is produce some kind of clustering to try and group similar customers together. So we want to maybe group into 3, 4, or 5 different groups of similar customers based on the values of the 4 variables we see here on the right. And if we were to look at this visually, and we can only in 2D really look at 2 different variables, let's take income and loyalty, by customer, we can see here in this scatter chart, you can kind of see there looks to maybe 2 distinct groups we have. However, if we want to do that with all 4 or even more than 4, then that becomes very difficult to do visually. And that's where clustering algorithms really come into their own, because they can work this out mathematically. So DBSCAN is an interesting new algorithm, and it's actually very similar to use to what you have already seen almost certainly with k-means. So how do we actually make a start in using it? Well, I've got some code here. It's very similar to what we've seen before. We're going to use the wrapper generator. We're going to create a procedure, then we're going to call that procedure. We're going to have arguments table. We've got input data. We'll probably do a view. We've got a results table as well. And in that results table, we're going to see for each ID what the assigned cluster actually will be. So in terms of the specifics here, again, you'll go to the manual to find out what do you need, for example, for the different parameters and for the different tables, such as the results table. In this case, you need 2 columns. You're going to have the ID, which relates to your ID from the input data, and a column which you can call whatever you want. I've called it cluster underscore number, which is an integer, which is going to be the cluster value starting from 0 that we have. So we're going to create a signature table, which has this table type information in it. We're then going to call the wrapper generator, calling in this case the DBSCAN PAL algorithm. We'll call our procedure PAL underscore DB, and that will then go out and generate. So let's run this code. And we can see that the types are created and we've successfully created the procedure. Now, in fact, if we were to go into our procedures area, we'd actually see that procedure listed. Now that's something we do once. What we also need to do is now actually create the physical parameter results table, and in this case we'll create a view because it does expect that we're having ID and then the 4 columns, not with the customer name. So to avoid materializing the data, we'll create a view. We'll create physical tables for the parameters and the results, and also I'm just going to create a little view for showing us based on the results table where we actually bring in the customer name as well. So we just join that back in from the original table. So let's do that. Let's create these views and tables. So again, that just took a couple of seconds to run. Now the parameter table is the interesting one. Here we've got some specific parameters. The number of threads is always very important. Put the maximum value you can to take advantage of the inbuilt parallelism that we have with the predictive analysis library, which is native to HANA and in memory. We have something called the distance method. And this basically is the approach that the algorithm is going to use in terms of how it actually tries to assign the clusters, how it works out the distances between the different points, the data points we've got. There are three methods we can use. We've got Manhattan, Euclidean, and Minkowski. For this example, we'll not get into too many details. We'll just run with the Manhattan, which is a very commonly used method. And also, a very important parameter is this one called autoparam. And by setting this value to true, it's a string value, it basically means that the algorithm is going to work out itself, whilst looking at the data, what the best number of clusters is going to be, and also work out what the optimal number of values per cluster, the number of IDs that we've got in each cluster, the number of customers in each cluster, and how far they should be from each cluster center, etc. So we can set some of these settings manually. For example, have a minimum of 10 customers if we use the min PTS. Minimum number of points. However, using the auto param option means that the algorithm will really try to find the best value itself. So it saves us some of that work. However, you could customize that later if you want. So let's populate our arguments table, run that code. Then the final thing to do is simply to run the procedure. And you've seen this before. We're going to call the underscore sys underscore fl pal underscore db procedure, and we'll call that. Let's run it, and it runs. It just took a very, very short amount of time. This is not on a massive volume of data. However, if we ran it on a large volume of data, it would still be very, very quick with HANA. And then what we want to do is to go to look at our tables. And in fact, if we refresh the list of tables, we will see that we have some new tables, the DB params. Let's just have a quick view of that so you get the feel. Let's data preview. Here we can see those were the parameters that we set, the thread number, distance method as 1, for example, auto param as true. And we've got our results table. And if we look at the preview of that one, we'll see we get a column for each ID showing us the cluster number. So this cluster number is the value from 0 to whatever number of clusters it defines. And in this case, we're seeing we only have 1. So in the analysis we did, it's created 2 clusters because it starts from 0. So this algorithm has decided that the best number of clusters that fits this data is 2. And interesting, that kind of relates to what we were seeing earlier when we saw that that scatter chart. And actually we've run on the same data set, we've run k-means many times actually for 2, 3, 4, 5, 6, 7 clusters, and that very often comes out that 2 is actually the optimum number of clusters for this data set. But the fact DBSCAN actually worked that out for us, we didn't have to go through them all and then compare the results. It actually worked that out inside the algorithm for us. Now, to make it a little bit more meaningful in terms of doing subsequent analysis, we've got the tables. We've also got a view, because we created a view there. We've got v underscore db underscore results. So if we were to preview this one, what we can see is we've got our ID customer and the 4 original values plus the cluster number, which is going to be 0 and 1 because we've got 2 customers. So now we can see the data in a little bit more context, and we'll be able to actually analyze that and use that data more easily later on. So that's a quick overview of how we've used DBSCAN, so density-based spatial clustering of applications with noise. You can do a little bit more complex things here, as I discussed. You can tweak some of the parameters. For example, you can turn off the auto and actually have, say, a minimum number of points per cluster, etc. So there's more complex things you can do. You can take it to a more advanced stage. However, I hope you've now had a good overview of what DBSCAN's all about and how it can help what you're doing with clustering.